You're only really as good as your weakest link on any machining process. Could be the machine, it could be the work holding, it could be the tool. So if you try and aim for the highest standards in each of those areas, then you're onto a winner.
So welcome to this week's MTD Podcast, a special edition this week. The reason being that earlier on this week, in fact on Tuesday, we had a live event happening at Fanuc UK at their headquarters on Anstey Park in Coventry. Now, the idea of the live event was to really showcase what a BBT30 machine is capable of. And boy, did we do that. And I have to say, I have the pleasure in this podcast of Andy Harvey from Fanuc UK joining us. Andy was behind the demonstration. He was the one that crafted it and pressed the cycle start button. Welcome to this podcast, Andy.
Hi Paul, Chloe.
How are you keeping? You all right?
Yeah, not too bad, thank you. Not too bad at all.
You've recovered from Tuesday's activities.
Yeah, it was pretty daunting, but yeah, we prepared well, and everything went really well. I was very, very happy with it.
Good. Now, what we're going to do in this podcast is we're going to talk about what actually happened on Tuesday, some of the demonstrations that we were cutting, and then, of course, if people listening to this are interested in knowing more about what the BBT30 Robodrill is capable of, they can, of course, contact Andy or one of your colleagues. I'm also joined on this podcast by Chloe Reeve. Now, Chloe joined the MTD team about 3 or 4 weeks ago.
Yeah, it wasn't long ago. It's been really, really an eventful time, going from being an engineer to coming into asking other questions on the other side. So yeah, I've really enjoyed it. Really enjoyed my time so far.
Good. So firstly, Andy, talk us through the demonstrations that we actually did see for those that did miss it at Fanuc on Tuesday.
So we did 3 demonstrations on Tuesday. We had a 10,000 RPM spindle prepped Robodrill. It was a medium-sized Robodrill, the advanced model, and we cut 3 demos, one in aluminium 6082, and one in medium carbon steel, and then a 304 stainless steel demo at the end. So three different materials, but I think we demonstrated just the ability of the Robodrill to be able to cope with those materials more than anything.
And what was the specification on the machine that we actually used, Andy, or you actually used?
So it was a medium model machine. So that means it's got a 500 millimeters x-axis travel. The 3 different models of Robodrill, small, medium, and large, differ only in that they have a 300, a 500, or a 700 millimeter x-axis stroke. So it was a medium one, 500 millimeters in the X, 400 millimeters in the Y, and 400 in the Z axis on this machine because it was an advanced model. So, yeah.
What's really interesting here is I think amongst the MTD team we were quite surprised at what the machines were capable of. Chloe, yourself, you've been on the shop floor, you've used machines, you've been involved in selling machines, but did you realise quite how capable? I mean, let's start with the aluminium demo that Andy was talking about. Did you realise quite how quick these machines were?
No, definitely not. And I think, what was it, Andy? It was just over 7.5 minutes.
Yeah, the alley was 7.5 minutes ish. Yeah.
And if you think about that and the size of the machine and the power of this machine in a BBT30, the amount of time in the application that it took to cut that material was absolutely outstanding. And the machine as well, doing the aluminium, the results on it was absolutely perfect.
I mean, did you have to incorporate things like through spindle coolant into this, Andy? How did you get rid of the swarf? What was the evacuation of all of that, and how important was that in the aluminium machining?
Yeah, so the aluminium, we did use through spindle coolant on a couple of the features, probably only the drilling, I think, now we're thinking about it. Yeah, we had some M16 tapped holes in there that we roll tapped. So the drill for that, we used a VDS drill from ITC that was through coolant prepped. So we used 70 bar through spindle coolant on that drill, which allows us to drive it, about 1700 millimeters a minute. So, yeah. But in terms of swarf evacuation, as Chloe said, it removes a lot of material quite quickly. So getting rid of that swarf or getting rid of the chips from the aluminium is paramount to keeping the machine going. So this particular demo machine is prepared with a swarf management system, an entry level management system, which has internal coolant wash bars to use coolant just to wash the dead areas of the machine and keep the swarf out of the way.
And how applicable was some of the operations that you performed in the demo to the general marketplace? What did you create, and why did you create the demo that you did? And I must say, for those, because we're on this podcast, if you want to actually see these demonstrations, you can go to our YouTube channel, which is youtube.com/MTDCNC to watch the whole of the live event. But yeah, what drove you to make this part?
Well, I think the three parts that we cut, the aluminium, the medium carbon steel, and the stainless steel, were all different. I'd say the aluminium was a lot different in geometry wise to the steels, mainly because of how representative the features were that we see every day in industry. Aluminium parts enclosures tend to have deep pockets in them and lots of tapped holes. So we tried to replicate some of those features on this demo piece. So we had two different sizes of pocket, one quite large pocket in the bottom, which used a 16 mm just to rough that out. But some shouldering and tapping. So we used an M16 roll tap in the Robodrill to tap some holes. So yeah, the aluminium piece had features on it which were representative of features you'd find on everyday sort of components throughout engineering.
And I think what was great about the event that we did is we started with the aluminium, which I think a lot of engineers have seen your machines ripping aluminium. People see people using Robodrills are performing like what you did during the live show. But where it got really fascinating, I think, for the audience, and we've actually looked at some of the statistics from the live event, and the two demos we're going to talk about now, the carbon steel and the stainless steel, are the ones that attracted the most views.
Okay.
And the most retention in terms of watching, which is no surprise because that's what we were promoting about the event. I mean, it was big cuts on small spindles, and that's really what we saw. Now, with the carbon steel demonstration, Andy, this was stepping up a level, wasn't it?
Yeah, it was. I mean, you go up a level in the hardness for sure, and your cutting tools and strategies change somewhat in the changeover from aluminium to steel. But yeah, that's just another demonstration of, you choose the right tools and the right strategies, couple them with a machine like the Robodrill, and you can get some really good results.
I think as well, Andy, with the two steels, they're quite similar in application, but obviously they've got quite different capabilities as material. And the Robodrill seem to go through them like nothing else I've seen. And obviously in the last one that we did, we could hear the chips and you could hear the machine working, and that's what people want to see. Do you think the Robodrill was capable and did a good job?
Absolutely. I really like the demo on the steel and the stainless steel. I mean, we've U-drilled steel before. We've done some quite good heavy cutting demos in the past. We did one a couple of years ago at Mac with the 40mm U-drill in steel, but we've never done it in stainless. So we wanted to show something a little bit different. We wanted to just push the level up a notch and show our customers and potential customers that the machine is capable of some really good metal removal rates on the harder materials.
And when I got home on Tuesday evening, I went onto LinkedIn and saw a post from you with a graphic of your heart rate when you you matched it to when you actually pressed cycle start. Had you on the stainless steel? Is that correct?
Yeah, as most people do these days, we have these those smartwatch type things that you wear, and when I sometimes go running, which ain't that often at the minute, but they monitor your heart rate, and I downloaded the information that evening, and it was bumbling along at sort of 60, 70, 80, 90-ish, And then about just before 1 o'clock, when we were getting into the nitty gritty of this demo, it went up to 165. So I guess I'm going to blame that on the cameras. It was nothing to do with the confidence in the Robodrill whatsoever.
Your heart rate, Chloe, was it?
Well, I was watching Andy from a distance, and obviously being an applications engineer, like
Yeah.
Andy, we even spoke about it, Andy, didn't we? We always, even though we've run that program 50 times through, we know it's going to work. We know the offsets are going to work. You always stand there, and you always get the jitters just before you press cycle start. And I presume that's everybody in applications.
Yeah.
Because there is something that can always go wrong, but thankfully on the day when all the cameras are on, everything seems to run smoothly.
It did, and there is always that feeling like obviously the machine was prepared. All the G10s were set right for those billets, but you're right. You only need one lapse of concentration, which, to be fair, in that kind of environment and when you've got cameras and people asking you questions, is possible. But yeah, you just double check like you do any other time you press cycle start, and everything was good. But
And for those engineers listening, Andy, what are the challenges that you face, do you think, when you're machining stainless? And what was it we were really trying to illustrate? Is it, strategy? Is it machine stability? What do people struggle with when it comes to stainless steel machining?
I think, well, stainless is a relatively tough material to machine. Let's face it. You go from a mild steel or a medium carbon steel to stainless. You've got that. The chips are different. The nature of the material is different. So you need to think about it in a subtly different way. Obviously, black and white speeds and feeds change. They generally, your cutting speeds will reduce and your feed rates compensate. But in terms of cutting tools, like I indicated on the video, the insert selection and was the same for the mild steel and the stainless. So we just adjusted the approach and the speeds and feeds, and we were able to machine both materials very successfully with similar tools. So yeah, it's just a mindset and a preparation, and making sure that you've dialed it in correctly.
Because when you look at maybe what people may compare this BBT30 machine in demo to, let's say a traditional BT40 machine, which may weigh 4 or 5 tons, it's a different animal to what we've got here with the Fanuc machine. You're talking about a machine that's smaller, a smaller footprint, it's lighter, it's got a differently configured tool changing system, a different spindle. So there must be some change in strategy that you have to adopt, or is the machine still as capable, even though those points I mentioned?
You're right. I mean, I guess the bottom line is really, could we have cut that on a BT40 machine? And the answer is quite categorically yes. Of course we could. We could have made exactly the same part on a BT40. But where we gain with the Robodrill over and above a larger machine is the reasons you've just said. Footprint is one. So we could fit, we may be able to fit 2 spindles into the space that one BT40 spindle might have gone. The acceleration and speed and of the tool changer and the dynamics of the machine mean that we could get around that component in the rapid moves probably a lot faster than a BT40 machine could. And we can certainly tool change a lot faster. So when you couple it up, yes, you could machine that part on a BT40 machine, no doubt about it. But could we have done it as fast as on the BT30? Maybe not.
And that's what I'm leading on to, Andy, as well. We've just spoke about the small footprint. You'd be able to do it on a BT40, but if you can get it done on a BBT30 machine and have that space in your machine shop, you've got probably more money than you would do investing in a bigger machine, but you're still able to get those cuts and get that accuracy in your Fanuc Robodrill.
Yeah, exactly. You're dead right, Chloe. I mean, we've had some examples in the past where thinking about a 24,000 RPM spindle option in the Robodrill, for example, that's a really good option. Not just for light materials like aluminiums and non-ferrous stuff, but if we're mold making, for example, the 31i control on the Robodrill is a brilliant control. It's got loads of different software options on it, so we can machine some very, very complex surfaces very, very accurately and smoothly. But we can also remove the excess stock from that quite hard tool steel, say a P20 or something along those lines. We've used 25mm diameter U-drills in a 24K spindle to machine holes in the corners of molds, and then use some quite large tools to remove that stock before ramping up the RPMs with small diameter 2 and 3mm ball noses to finish off. So we can do the whole lot on a Robodrill. You may have had the down low grunt in a BT40 machine to remove the stock, but you may not have had the increased RPM and smoothing capabilities of the Robodrill to finish that mold off. So we can perhaps look at it. We may be slightly slower on the roughing, but if we can do the roughing and the finishing in one go on the Robodrill with minimising the post-processing, then that's all good.
And you mentioned that you got the 24K option as well. Could you have done what you did on Tuesday with the 24K machine?
Not everything. The 24K spindle would have performed in the aluminium better. We could have machined that aluminium piece quicker, I think, with the 24K spindle. But the 24K spindle has around half the torque value of the 10K. So the large U-drilling and big 80mm face mills on the steels, we wouldn't have been able to machine that successfully on the 24,000 RPM spindle. We'd have had to alter our approach again, just to what we'd gained on the aluminium, we'd have slowed down on the steel. So it's all about compromise when you're machining different materials. I think.
What risk is there to the spindle with the way your tool changer, turret, however you describe it, is built and supported? When you do start hitting the harder materials, is there an advanced risk over a more typically styled tool carousel? How is it made, and how does it handle what we've just seen or what we saw?
Well, the tool changer on a Robodrill you'd say it was probably one of the best features on it. It's design, how it's mechanical, fully mechanical, really. So there's very few parts on there to go wrong. So that gives it its reliability. But it's so simple that when the Z-axis retracts away from the work and it goes away to tool change, it comes straight up in the Z-axis. And as it retracts in Z, the tool changer swings into position on a cam and takes one tool out. And as it indexes, picks the next tool up, it's driving back down in the Z-axis, which is accelerating to pick the tool up, and it's back down into the work again. So the dead time associated with rapid moves and positioning during tool change is really, really minimised on the Robodrill. So I think the tool changer is an exceptional feature.
The tool changer, Andy, is probably one that's most unique to Fanuc, but also what's unique to Fanuc is your coding system. So I think it was a 31 Fanuc we had software.
Yeah, 31,
Yeah, so explain to me how well, obviously customers have the Fanuc and they use the G code, the manual guide, but explain to me how well the Fanuc works with the Robodrill and how they interact together.
Well, it's really good having a Fanuc machine, because we've got a Fanuc machine, Robodrill, we've got Fanuc servos, amplifiers, a Fanuc control, so it's all coupled together in one place by one manufacturer. So that gives us a really good interface between all those components. And also, really, there's some features on the 31i controller on the Robodrill that you wouldn't find on other 31i B5 controls on other machine tools. So Fanuc have customised that control to fit the Robodrill and given it some really nice features to go along with it. So for a machine of the cost and size of a Robodrill, to have that control system on it is mind-blowing. It is such a powerful control.
And I have to say at this point, for people that did miss the event, it is on our YouTube channel. If If you go to youtube.com/MTDCNC, you'll be able to watch the full hour and 20 minutes where we did 3 demonstrations, one on aluminium, one on carbon steel, and one on stainless steel on the Robodrill. Part of the association or collaboration was, of course, ITC. They were present on the day, and it was their cutting tools and their tool holders that you used. How important is that aspect, and what does the ITC product give to or help or assist in the Robodrill to produce the results it did, Andy?
Well, I mean, you're only really as good as your weakest link, aren't you, on any machining process, whether that be, it could be the machine, it could be the work holding, could be the tool. So if you try and aim for the highest standards in each of those areas, then you're onto a winner. If you keep holding your part, we're using some good solid work holding, you can forget about that aspect of it because the part's not going to move anywhere. I've obviously got a lot of confidence in the Robodrill and its control, so I wasn't worried about that. And with ITC and the big Kaiser and NVIDIA tooling, I really didn't have to worry about that too much either because it's just first class. Obviously, the Robodrill has got a big plus spindle, so BBT30. We use the gauges from Deshauer, so that spindle nose is gauged using big Kaiser Big Deshauer gauges. So if we're using gauges from them to make the spindle nose, that interface coupled with a big Kaiser tool is going to be pretty much, it's going to be perfect, isn't it? The face and taper contact, and it gives that lovely increase in stiffness over a normal BT30. So yeah, it's their tooling and my new favourite, that video, the Vary Mill. They did a great job really with supplying us some wonderful tools to use.
Yeah, definitely, Andy. And also, me and you talked about on the whiteboard the gauge length on the BBT30. So, give me some advantages of the BBT30 over a BBT40. A BT40 tool, because the amount of power that you've got, especially with that U-drill going in on that steel, was outstanding.
Yeah, no, it's it takes an awful lot of torque. I mean, we're pulling almost 85% of spindle load in the stainless using that U-drill. So, you need a rigid interface. You need the tool to be held nice and solidly. I think where the BBT aspect of it, the face and taper, comes into its own is when you're using larger diameter cutters or you're applying quite heavy side loads. So, say for example, the 80mm face mill we used on the steel, you really need to support that cutting tool as big a gauge diameter as you possibly can. So, cylindrical objects will bend. The longer they are, the more they'll bend. That goes up in a non-linear curve. It's not exponential, but it looks like that shape. So the bigger diameters you can support on, the better. So to have a BT30 style size of spindle with a BBT interface gives you the best of both worlds, because you've got that low inertia of the size of the BT30 spindle coupled with the large gauge diameter interface of a face and taper BBT spindle nose. So you get that extra stiffness and rigidity that you wouldn't get on a standard BT30. So yeah, it's perfect.
And do you think that we mentioned about the aluminium demo and how in the marketplace people were performing those types of operations and similar machining strategies? Do you have customers that are before this show that went out actually machining stainlesses, or was this just something that we were doing to show it could do it? But in reality, does it happen frequently?
I think it does, but not. I wouldn't say frequently. I think I tend to find on my travels that we're machining a lot more softer materials, so plastics and non-ferrous aluminiums maybe, than we are sort of ferrous materials. The Robodrill gets used an awful lot for machining castings, so we will find some iron castings in there, but components from higher hardness steels or alloy steels and exotics is something that we see every now and then, but not so often. So I think we want to try and open people's eyes a little bit to the fact that the Robodrill can handle the harder materials, and it handles it well. Funnily enough, I went out yesterday to a customer, and they'd seen the footage and watched some of the MTD events that we, or some of the footage of the steel cutting. And two guys, and one turned to the other and said, "You realise they used an 80mm face mill on that machine?" And so they were genuinely, and this, I'm not just saying this was a genuine conversation I had with these two guys, both CAM programmers. So I think they were, I wouldn't say shocked, but they were surprised of the capability of this small little machine in the hard material. So it's good.
It's incredible, isn't it? I mean, we're fortunate, us three being in the sort of positions that we're in, where we're able to, see it from the top, really, experiment, spend the time researching. When you're on the shop floor or you're working from day to day on the business, you just don't get the chance to do the things that we did. And that's really why we did that show. And it's pleasing to hear that. I mean, in terms of its traction so far on our channels, it's seen over 4,000 watches.
Yeah,
and I was just saying to Chloe earlier that it's still being watched at the rate of 50 views per hour. But bearing in mind that the average view rate is around about 15 minutes as well. So it's been a tremendous success, and I'm sure a lot more of this sort of activity, and you will see a lot more robo drills with the BBT30 spindle out in the field cutting stainless steel. And you'll probably also find a lot more people with Apple Watches and having their maybe when they try, but maybe that's something that we'll all get used to one day. Who knows?
Yeah, absolutely.
But we're going to wrap this one up now, Andy. It's been a great week this week for us working with Fanuc. Tuesday was superb. I know this podcast will probably come out in a week or two's time, so for timestamp reasons, it was actually was it the 9th of March, I think, that we actually shot.
Yes. Yeah.
It was the 9th of March. It was a live event. It's on our YouTube channel, mtdcnc.com/YouTube. You'll be able to still find it, and I'm sure by the time people are listening to this in a week or two's time, it's probably been watched 7,000 or 8,000 times, and I'm sure a lot more people will be speaking about it. Once again, Andy, thank you very much for Tuesday and today, and I'm sure we'll be doing another one of those in the near future. And thank you, Chloe, for joining us today.
I'm really looking forward to it. It's been a pleasure. Thanks, guys.
No problem.
Thanks, Andy. Cheers, mate.
Thank you, Chloe. Cheers.
Thank you. And that's it for this week's MTD Podcast.
Thanks for listening to the MTD Podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.